Hi there. We're going to continue our work with raising I to various powers. And before we begin with that, I would like to remind you that there are two facts you need to remember. The first is that the square root of -1 will be equal to I always. And that when you raise I to the power of 2, the result is the real number, -1. So although this fact is completely imaginary or complex, this fact actually results in a real number. All right, so when you raise I to various powers, there are 4 different results possible. And those results are either going to be the number +1 or -1, positive I or negative I. So these are the possible results that you can get when you are raising I to various powers. We're going to talk about the pattern required to figure out which one it is. We do know that according to fact number 2, the first time we get a -1 is when we raise I to the power of 2. Obviously, when we raise I to the first power, it's going to give us an I. So we will write that down here. I to the first power is also going to give us I. The first time we get a result of +1 is when I is raised to the power of 4. And the first time we get -I as our result is when we have I to the power of 3. I will go back to this fact here where the result is -1. The next time that we get -1 as our answer is when I is raised to the power of, not 4, 6. And then after that, the next time is when I is raised to the 10th. Now you may have noticed that what's happening here is that if you add 4 to the original power, as long as you start with I squared, when you add 4 to the power, if you increase the power by 4, you will always get -1, which means that the next time you will see -1 is with I to the power of 14. In order to get +1, like we said, the first time you get +1 as a result is when you raise I to the power of 4. The next time is when you raise I to the power of 8, and then also I to the 12th. You can see that this pattern is very similar, it's just that it starts with I to the 4th. If I increase the power by 4, and I'm saying increase, not multiply, but increase the power by 4, starting with I to the 4th, your result will be 1. So that means the next one would be I to the 16th. You may have noticed that all of these powers are positive, and that is true. Now let's see what happens on the other side. I'm going to rewrite this so it's in line with my I to the 3rd. So I hope that's not too confusing. But we know that the first time we get just I is when I is raised to the first power. The next time we get the answer of I is when we raise I to the power of 5. Then again to the power of 9. And if we continue with this pattern of just adding 4, again when we raise I to the power of 13. You'll see that here the first time we get negative I, the first time we get a result of negative I is when I is raised to the power of 3. The next time is when I is raised to the 7th, and again when I is raised to the 11th, and again we are adding 4 or increasing the exponent by 4. So the next one would be I to the 15th. You may have noticed that all of these initial powers or exponents are odd numbers. While these are even, all of these initial powers are odd. Why am I pointing that out? If your initial power, meaning all of these, like all of these here, if your initial power is even, then your result will always be either 1 or -1. That's for the initial power. Does that make sense? I hope it does. If your initial power, like these, are odd, that means the power we start with, then your result will always be either I or -I. Hopefully you're seeing that pattern. Now, the difference between whether it's a positive or negative is a little more subtle, and it requires us looking at I squared a little more closely. We're going to start up here, and we're going to break down each of those powers into how many pairs of i's there are in that set or in that expression. What do I mean by that? I could say that I to the 4th is actually the same as I squared raised again to the power of 2. What I'm saying there is that I have 2 pairs of i's. And since I squared is actually the same thing as -1, this is the same as -1 squared. And we know that -1 squared will give us 1. I'm going to try this again with I to the 8th. I to the 8th can be rewritten as I squared raised again to the 4th power. What I'm saying there is that we have 4 pairs of i's when there are 8, when the power is 8. So now we know that I squared can be rewritten as -1 raised to the 4th. Well, we know that -1 raised to the 4th is going to give us +1. I to the 12th is the same as I squared raised to the 6th, which means that this is really -1 to the 6th power. Again, we get 1. I to the 16th is the same as I squared raised to the 8th. That's the same as -1 to the 8th, and -1 to the 8th will give us 1. If you pay close attention to what's happening here, you can see that the number of pairs of i's, in other words, this power out here, the number of pairs of i's, are even. So if the number of pairs of i's are even, you will get a positive answer. Let's contrast that with this result, or the results from this part down here. I squared is simply I squared to the 1st power. I squared to the 1st power is -1 to the 1st power, which gives us -1. I to the 6th is really I squared raised again to the 3rd power. In other words, we have 3 pairs of i's in I to the 6th. Remember, that's like saying -1 raised to the 3rd, which definitely equals -1. I to the 10th is the same as I squared to the 5th. In other words, it's 5 pairs of i's. And so negative 1 to the 5th, of course, will give us negative 1 again. I to the 14th is going to be 7 pairs of i's. Negative 1 to the 7th definitely gives us negative 1. What you may notice here is that the number of pairs of i's, is odd, which gives us a negative answer. This is not going to be a whole lot different over here when we're dealing with the odd numbered powers. I to the 1st doesn't have any pairs of i's in it. We know that that's just going to be I, so I'm not going to rewrite this one, but I will rewrite I to the 5th. I to the 5th is the same thing as I squared raised to the 2nd power times another I. There are 2 pairs of i's, making this I to the 4th times another I. If we have an even number of pairs of i's, we know our answer will be positive. And this expression, when you square negative 1, makes it a positive 1. Positive 1 times I gives us a positive I. I to the 9th has 4 pairs of i's with an extra. It's like a remainder. If you raise negative 1 to the 4th, altogether this is 8, right? 8 i's. If you raise negative 1 to the 4th, you get 1. 1 times I equals positive I. I to the 13th can be written as I squared to the 6th. It has 6 pairs of i's with an extra. Raising negative 1 to the 6th power gives us 1. 1 times I is I. You'll notice that again we have an even number of pairs of i's, resulting in a positive answer. Down here, when we're looking at these, I to the 3rd has only 1 pair of i's with an extra. Negative 1 to the 1st is negative 1. Negative 1 times I is negative I. I to the 7th, there are 3 pairs of i's with an extra. Negative 1 to the 3rd is negative 1 to the 3rd is negative 1. Negative 1 times I gives us negative I. I to the 11th has 5 pairs of i's with an extra. Negative 1 to the 5th is going to be negative 1 times I gives us negative I. And finally, I to the 15th has 7 pairs of i's with an extra. Negative 1 raised to the 7th is negative 1 times I gives us negative I. You'll notice that here we have an odd number of pairs of i's. Okay, so this pair of i's is something different than the number or power of the I at the outset. Okay? So how do I summarize this? An even number of pairs of i's will equal a positive answer. Okay, it will equal a positive answer. An odd number of pairs of i's will equal a negative answer. What do I mean by pairs of i's? Obviously, I'm talking about I squared. How many I squares are in that original power? Let me show you two examples of how you can work this out without having to refer to this. Let's go with I to the 50th and I to the 51st. I to the 50th has 25 pairs of i's in it. That means that I am raising -1 to the power of 25. That means my answer is definitely -1. I to the 51st also has 25 pairs, but it has an extra. We already saw that this result is the same as -1 raised to the 25th, but with the extra I. That means that I am multiplying -1 times I, so my answer will be -I.